Have you ever thought about those big mysteries out there? The ones just waiting for someone to come along and crack the code?
It's like a puzzle, isn't it? Knowing there's something amazing to discover.
Exactly. It's like staring at a treasure chest but not having the key.
And in math, we have these metaphorical treasure chests. They're called the Clay Mathematics Institute's Millennium Prize Problems. 7 unsolved problems, each with a $1 million prize.
Wow, $1 million. That's some serious motivation to hit the books.
Each of these problems could completely change how we see the universe.
I have to admit, though, I've always been a bit intimidated by high-level math. Are we going to be doing calculus today? Because I don't know if my brain's ready for that.
No calculus today. Think of this more like a behind-the-scenes look at these problems. We're not going to get lost in equations.
Okay, that's good to hear.
We're going to talk about why these problems are so interesting, even to people who aren't mathematicians.
All right, I'm all for that. So what's the first mystery we're diving into?
Let's start with one that sounds pretty straightforward. P versus NP.
P versus NP. All right, lay it on me.
Imagine planning a road trip across the country. You want to visit all the best spots.
Yeah, hit all the landmarks, see everything.
And you want to do it all in the shortest amount of time.
Sounds like my kind of road trip, but also like a logistical nightmare to plan.
Exactly. So many routes, so many possibilities, and that's what P versus NP is all about. It asks, if you can quickly verify a solution's correct, does that mean you can also quickly find that solution?
So, like with our road trip, if I can quickly calculate the total distance of a route, does that mean I can also quickly find the absolute shortest route possible?
Precisely. And this question, it has huge implications, everything from unbreakable codes to super efficient algorithms.
Okay, now you've got my attention. Unbreakable codes. That sounds serious.
Think about your online banking. It relies on systems that are really hard to break.
Right.
But what if there's a shortcut? What if there's an algorithm that could crack those codes in no time?
Yikes, that's a scary thought. So P versus NP is about figuring out if those shortcuts exist.
It's about understanding the limits of computation. What can we solve quickly, and what's going to take forever, even with the most powerful computers?
So solving this problem wouldn't just be a win for mathematicians. It would have real-world consequences for all of us.
Absolutely. For things like cybersecurity, online privacy, even things we haven't thought of yet.
Wow, I never thought about math having that kind of power.
That's what makes these Millennium Prize problems so fascinating. They're not just abstract puzzles, they're keys to unlocking deeper truths about the universe.
Okay, I'm hooked. What's the next mystery on our list?
Let's move on to the Hodge Conjecture.
A Hodge Conjecture. All right, what's that one all about?
It's about shapes and dimensions. But imagine you're building something complex, like with Lego blocks.
Okay, I can picture that. I love Legos.
Now imagine you're not limited to just 3 dimensions. You can build in higher dimensions.
So like 4 dimensions, 5 dimensions, that's hard to even imagine.
Exactly. And that's what the Hodge Conjecture is trying to understand. It's about the building blocks of these complex shapes, how they fit together, and the rules that govern their structure.
That's pretty abstract. But I guess even abstract math can have real-world applications, right?
It has deep implications for fields like theoretical physics and engineering.
Okay, so we might not be able to picture these higher dimensions, but understanding them could lead to some amazing breakthroughs.
Absolutely. We might be able to design materials or structures with properties we can't even comprehend yet.
That's pretty mind-blowing. But how are we supposed to solve problems that deal with dimensions we can't even visualize?
Well, that's where things get really interesting. Our human minds might struggle, but what if we had a different kind of mind working on it? And that's where AI Quotient comes in.
AI Quotient. That's the company trying to use AI to solve these problems, right?
That's right. They're using AI agents, programs that can learn and solve problems on their own.
And they think these AI agents could hold the key to these mathematical mysteries. I mean, can they really do that?
That's the big question. AI has already done amazing things in other fields, but can it crack the code of pure mathematics?
Well, if anyone can figure it out, I guess it would be these AI agents.
Yeah.
But how would they even approach a problem like the Hodge Conjecture?
The exciting thing is that AI agents don't think like humans. They see things differently.
So they might be able to find solutions that we would never even think.
Exactly. They can analyze huge amounts of data, find patterns we might miss, and even come up with entirely new mathematical frameworks.
It's like giving them a fresh perspective on these problems that have been stumping us for years.
And it's not about replacing human mathematicians. It's about giving them a powerful new tool.
A new way to collaborate and explore these uncharted territories of mathematics.
Exactly. And who knows, maybe this partnership will lead us to breakthroughs we never thought possible.
I'm starting to see the potential here. All right, I'm ready for the next mystery.